I'm Stephen Ellison. I work for a company called The Light Source. And yes, we do make LEDs, but today I want to talk in generic terms about LED fixtures and the difference between LED fixtures and what were the original fixtures we started with. If you go back far enough, it was candles, but we're not going to go that far back. But to go back and compare against the metrics that were tungsten halogen, or even before that, just regular tungsten filaments. How much has changed? Well, we talk about basic fixtures. Let me get my PowerPoint going for you. And we'll give you some idea what I'm talking about. So this is lighting fixture metrics we want to talk about. What are performance metrics? Just so you know, it's a fun term, sounds good. It's the data we're going to talk about for a fixture. These metrics are defined by organizations outside of the manufacturer that's making the fixture. So your IES files, things like that. An example is measurement. You know, straight standard thing. How big is it? So that's a very fixed value. The National Institute of Standards and Technologies actually publishes and maintains, you know, how big is something. The United States, we deal with inches. Everybody else in the world deals with millimeters. But there are precise measurements. So we can't change that. That's a performance metric that the manufacturer has no option but to give you the real thing, because you can check it. You know, your tape measure is just as good as theirs. So LED fixtures. What's the difference between that old fixture that I grew up with and these new ones that basically have taken over? I mean, easily it's the lamp type. We had tungsten halogen lamps, so you just had one thing you could do with that tungsten halogen lamp. You could dim it, you could take it up and down. You couldn't change anything. You couldn't change the color of the lamp output. You were stuck with the color that it was. Now you could get different color temperatures, and we'll go into color temperature farther down in this presentation, but you couldn't change that once it was chosen. The weight of the fixture, there wasn't a lot to it, so they didn't get very heavy. You're going to find that your LED fixtures are much heavier, so you're going to have to take that into consideration in your rigging, that they're actually more weight to the fixtures, because you've got things like heat sinks, you've got power supplies, ballast, things of that nature. And the control is much different. In this day and age, we talk about DMX as being the main control we want to work with. There are other methods of control, but a tungsten halogen fixture basically had one attribute. It could go up and down, it could dim, it could become brighter, it could become dimmer, but it couldn't do anything else. Now we begin to talk about LED fixtures. Well, I can dim an LED fixture up and down if it's just a white light, but they begin to use up more attributes. If we just talk about color, you've got red, green, blue, okay? That is an attribute each. So that's 3 attributes. Now, if I want to talk about them in a dimmer, that's a 4th attribute. Pretty straightforward, but a lot of these fixtures now have red, green, blue, amber, lime, white. You're adding more and more colors, you're adding more and more attributes, which means DMX channels. So your control gets more complex. Also, we used to, the older fixtures, and they're still around in the moving lights, the arc lamps, moving lights begin to take up a lot more space and time in the control system. Think about it. If every control thing that you want to talk about, other than the color of the lamp, is going to be a attribute. And they're all controlling the stepper motors. So that becomes to make a difference. So the metrics grow as to what the control is, how many control channels you have to know about. And that's a defined thing. Again, you can't change what that is. It's defined by somebody outside of your ability to control. So that's sort of the difference between the old and the new. But some of the things that aren't different, when they first started coming out with LED fixtures, they were just simply a wash fixture. If you, as a lighting designer, know, you've only got really two different types of fixtures in the fixture tree. You can either focus the image or you can't. A focusing fixture is an ellipsoidal. And interestingly enough, I was wondering for years, how are they going to get around that? Because the ellipsoidal reflector spotlight that I grew up with required a lamp that produced a single point of light. And then lenses focused that image so that you could project the image. The first thing you thought about when you projected the image was the gate in the lamp, because that was a circle. And then you brought in shutters, and you could have shutter cuts, and you could focus the edge of that shutter cut, and then you could put gobos in, and you could focus the gobos. So I was always concerned, how were they going to get around that? And they figured that out. The optics have gotten really good, and so ellipsoidals are now available in every kind and shape that we grew up with in the tungsten halogen world. So you've got wash fixtures, which came out first, and they're pretty straightforward. You take a lamp, you put a lens in front of it, and you've got a soft edge. The original LED fixtures were just the LEDs themselves mounted to a board with the little cup, the little jelly bean looking things. And so they would populate a board, and that became the thing. They were kind of inexpensive. They first started out really making headway in the DJ world, the clubs. They didn't make it to the really fancy theaters for a long time until they got better and brighter. So basic metrics we can talk about as we are talking about these lighting fixtures. Obviously, dimensional. The dimensional size can make a difference. Maybe it doesn't. Basically, they're all fairly much sitting in the same dimensional size that you would find of another fixture. The Parcan, it looks the same. They basically made it identical. The ellipsoidals are basically identical. The same lens tube can be used in the old fixture and the new. So a lot of them are now making it so that you can change the back end of the fixture and keep the front end. So dimensionally, weight is a factor. You will find you have to deal with weight. Electrical is really different because one, power goes way down. The standard lamp that became, fairly much ubiquitous was the 575 watt or 500 watt lamp. That's putting out a very nice amount of light. They got real good with it. But that's basically 600 watts, close to. Now, 100 watts is fairly standard. The bigger, the really powerful ones, 230, things like that, maybe 300. But they're still less by a lot because the 300 watt lamp is going up against an arc lamp of 1200 watts. So we're really getting into a different level of how much power. We are saving power. There's going to be a thing to calculate that's going to make a difference because we were used to, if I could, I'd like to dim everything independently. So I would only put one lamp per dimmer, but dimmers were, expensive, and you only had so many dimmers in your theater. So you would actually decide, well, I'm going to join a couple fixtures together. And the most you could do was 4 575 watt lamps to get you up to 2300 watts, which would just fit into a dimmer, a theatrical dimmer, mind you, which had a breaker which was designed to handle that full load. Power factor. If you haven't heard of power factor, that is something which now makes a difference. Power factor for a standard incandescent lamp has no effect. Power factor is dealing with switching power supplies. And so that has an effect on how much power the neutral actually sees. And that's becoming something that makes a difference. If you can achieve a power factor of 1, you're back to being a tungsten halogen lamp. But you probably can't. So the worse the power factor, the worse the size of the neutral needs to be, how big it needs to be. And so you got to calculate that in, that you're going from everything being easy to suddenly you're loading up the neutral in a lot more, computers. Nowadays, offices didn't have computers. Now everybody's got a computer. They're using switching power supplies. So you'll find that the electrical engineers are dealing with that and they'll understand it, but they'd like to know that information. And the manufacturer should be able to give you that. So inrush current. Here is where it makes a difference as to how many fixtures you can put on that one circuit. Now, we're switching to where we're going from a dimmer to maybe a relay or just a regular breaker. And a regular breaker is rated at 20 amps with a derating factor down to 80%. So they're only good for 16 amps. Now, they should be good for 20 amps on a short duration, which is inrush. But inrush current is the current being drawn by a fixture at startup. It is not the current that is being run, it's not the power, because normally the power will be rated either in watts or in current, amps. But the inrush current can be a lot more and can affect that if I have 8 fixtures at 100 watts, that's only 800 watts. That should be well below the rating of the breaker. But if their inrush current is equivalent to 500 watts each, now it makes a big difference. Now that might be milliseconds, and so you may be good, it may work, you may not have a problem, but you never can tell whether the inrush current is going to be more than the breaker can handle. So the manufacturer should be telling you exactly how many fixtures you can put on a breaker or a circuit. Something that makes a difference, because you'll say, well, it's 100 watts each, because you didn't have inrush current of any factor in a dimmer system. An incandescent lamp, you turn it on, it's 100 watts, you're drawing 100 watts from the beginning, or as you dim it up, you reach it, you go from 0 to 100 watts. Inrush current's major change is that the power supply can draw that much more power for that very short period of time. So that becomes an interesting thing to worry about. You might say, well, I don't have a problem. And the first time you throw that breaker, it pops immediately, and suddenly you don't have control, your lights just don't work. Vampire power. I love that term for it. It's a great idea. What is it? That's the power that the fixture is drawing when it is not putting out any light. Okay, so an LED fixture, when you say it's a 100-watt fixture, that is when you are seeing 100% of the output of the light, because LEDs, they're an electronic chip, and when you get them going, they'll output light. So you get 100 watts of light output. Well, when I turn off the output of the light, I don't turn off all the power going to that fixture. An easy example that people don't, think about too much is you have a TV. Everybody has them, and they'll have a little light down in one corner, and you see nothing on the screen. It's black, but the light's on. And if you hit the power button, the TV comes up pretty quick. That means that the circuitry, the electronic circuitry in that TV is always on. When you hit the power button, you're blanking the screen and you are taking it to a low power state. But that LED, that little light down there in the corner, tells you that you are still getting power draw. So you're still having something happening and you're consuming a certain amount of electricity. They even say that you have that wall wart that you plug your phone into is drawing a certain amount of power. You know, if you really want to make your house as power energy efficient, you want to turn off or unplug all of those wall warts and turn your TV all the way off. So that's an important thing to note, is how much vampire power are you drawing? Now, for most theatrical lighting rigs, you're going to turn the power off to the fixtures completely anyway when you're not using them. So when you're not in the theater, you're going to have that fully down and off. But that might not apply because you're switching to LEDs for your house lights too. And so for your house lights, you might want that circuit card to be on, because if you've got power going to the circuit card, it's already on. And something to think about is if you've got to power up that circuit card first before it actually outputs light, meaning it listens to the DMX input and tells the LEDs to turn on, well, what's the first thing it's got to do? It's got to figure out what's happening. So it's got to power up and the central processing unit, meaning every LED fixture is basically got a little computer in it because it's listening to DMX, and DMX is digital language. Digital meaning you got to have a computer to interpret what is coming across the line. So if I have to wait for my central processing unit to turn on, think about how long it takes you to start your computer up. Well, LEDs don't take that long because they don't have that much to do to get ready to go. But it can take 2 seconds. It can take 1 second. It has a certain amount of time. It's always going to take a certain amount of time to come up and actually get going. So you got to think about that as you're doing it. Do I want these to be drawing a certain amount of power, or can I turn them all off? One of the reasons you want to turn them all off in your theatrical rig is cooling. That's our next thing on the list. Noise. Well, a lot of LED technology that people don't understand is heat. LEDs actually generate a lot of heat. You don't notice it because they're only 100 watts, but at the junction point of the LED, and we're talking this little tiny point, that's where the heat is. You've got to get that heat away or the LED is going to die. They don't live very well if they get too hot. So there's got to be some method of getting them to be cool. So you've got 2 methods. One, big heat sinks, convection cooling. You know, you've got a good way to get the connection between the junction point on that LED out to the heat sink so that you get the temperature to go down. It pulls the heat away. Well, the other method is you blow air on it. So you've got some heat sink, but it's not as big. And so you got a fan blowing on the heat sink that then keeps it cool. So that ends up cooling the thing, but then you got a fan noise. And fans can add noise to the system. So you got to think about that as to what you want to do. That's why a lot of rigs, they turn off, especially the moving lights and things like that, so that they keep it cool in the background. Or you got convection cooling. Data protocol, dimming, that's a basic metric. If you're going with something other than DMX, you're going to have trouble getting good, clean dimming. Doesn't affect most of the theatrical fixtures you're going to deal with because they're all going to be DMX. It's going to affect your house lights where they make a difference. 0 to 10 dimming, which is one method, one, you lose control. You don't get to have all of the control. You're going to do a group of fixtures instead of individual fixtures. Then you're also not going to get down to 0. They're going to blink at some point. So I recommend, if you're doing something that's got control, put in DMX, because you can guarantee you're going to get a good theatrical dimming curve. The last metric that I'm going to, no, well, not the last, but warranty. Leaving those other ones. Warranty is something you want to know about. It depends on how long you need the fixtures to last. You could be doing a youth room, 10-foot ceiling, inexpensive fixtures. You want to spend the least amount of money, and if the fixture dies, you just throw it in the trash. That's an inexpensive, cheap fixture. You can replace it easily, and there'll probably be new and better ones out 2 years later anyway. So the least amount of money you spend, it's going to be great. In your main sanctuary, you may want to think about that the fixtures are 25 feet in the air, and it takes a scaffolding to get to them or a special lift that you got to drive in and rent. So they're hard to reach. So you might care that they've got a longer warranty and they're designed for a lot longer life. Like their electronics are designed like your TV, that they last a long time. Your electronics in a TV, think about it. I've had TVs, they're over 10 years old. They're still running fine because their electronics are designed for that kind of life. Whereas you can design some really cheap, inexpensive circuitry. It'll give you good dimming. It'll control your LEDs. You put a fan in there, you put a 2-year warranty on it. That's, fine. At the end of 2 years, if the light dies, you only spent $75 to $100 or less on it. No problem. Throw it away. Get a new one. By then, they might have come out with another and better, little light, so you think about that. One way to know how long your fixtures are designed for, that number L70 down there at the bottom of the screen. L70 stands for how long, and it's an interpretive thing. They don't know precisely, nobody's done it, but the L70 rating is how long your LEDs will last down to 70% of the original output. So LEDs aren't like tungsten halogen lamps. Tungsten halogen lamps die. The filament breaks, you go from light to no light automatically, and you're never going to get it to come back. Sometimes you bump it and it'll flicker, but that's only the filaments brushing up against each other. It's not going to last. LEDs don't do that. They fade away. At their L70s, 70%, they're still outputting light, and they might do that for another 5 years. They're still going strong, kind of, but the rating is that, your output is going to be dropping and you're suddenly going to lose output. So how much light you're going to see is changing, and the foot candles are going down, and it might take you 50,000 to 100,000 hours to actually see that. 50,000 is most common rating, and 50,000 hours is a long time if you're not using your space that much. I mean, if you're using an ellipsoidal every day, maybe not. Maybe it's Wednesday nights when you're having choir rehearsal, or Wednesday night for service, Saturday for choir rehearsal or band rehearsal, and then Sunday morning. Sunday morning, you use them from 8 to 11 or 12, and you're done. That's not a lot of hours. House lights might get more use, they might get less. So you got to think about that 50,000 hours will last you a long time, but the warranty on the fixture might not last that long. The warranty on the fixture might be shorter, or shorter only in that it's based on years, not hours used in the year.